right, now we're going to apply some of the things we've learned in a few different contexts. So first I'm going to talk about density. We know that gases are very low density, right? They take up a lot of space but have very little mass. Density is still mass over volume. It's just going to be very small for gases. So the equation for density looks like this. I kind of call it the dump dirt equation because it looks like it says dump dirt. This is on your equation sheet. The density is equal to the big M stands for molar mass times pressure over R, same R we've been using, that constant, times T. And this would be how you calculate the density. Or if I give you the density, how you calculate something else. So unit wise, you do need to watch your units. Your molar mass should be in grams per mole. That's what you pull off the periodic table. And then your density is going to end up being in grams per liter. Okay. Usually we do grams per milliliter, but since gases are so low density, it's going to be grams per liter. So example number 10 says what pressure would be required for helium at 25 degrees Celsius to have the same density as carbon dioxide at 25 degrees Celsius in 1 atmosphere. So this is definitely a multi-step problem. I give you some information about one and you have to calculate the other. So anytime you have these problems, again, you want to approach it, be like, okay, what do I have and what can I do with it? If you see the word density, you're going to have to use the density equation. All right. So I want to know pressure. That means I need molar mass, R, and temperature. Okay. Now I'm looking for helium. We know the molar mass of helium is 4 grams per mole at 25 degrees Celsius, which is 298.15 Kelvin. To have the same density as carbon dioxide at 25 degrees Celsius in 1 atmosphere. So what we're going to have to do, the approach for this is going to be calculate the density of carbon dioxide and then use that density, which ends up being 1.7984 grams per liter, to calculate what the pressure for helium would be to get that same density. So you would plug in that density and then solve. Okay? So this is really like using 2 density equations, calculate for one and then the other. This is a really good example of one that would require a problem solving approach. Okay. Again, check what you've got, plug in and solve. You're good. Okay. So another way that we can use this density equation, if we rearrange it, we can use it to find molar mass, right? So if I didn't know what a gas was, we could find the molar mass. So we do this in lab a lot because we can measure the temperature and the pressure of a gas, and then we could identify it by calculating the molar mass. So example number 10, I think I'm going to do that one with you. Okay, so reading through this question, I've got, let's see, this is a mass of a gas. I don't know what it is, so I don't know what the molar mass is. Occupies a volume of this. So V is, I'm going to go ahead and put that into liters. 0.2000 liters at 99 degrees Celsius. So my temperature is 372.15 Kelvin. And then I have millimeters of mercury. Again, I'm going to go ahead and put that into the unit that I need it to be, which is going to be atmospheres. Because I'm going to use the R that has atmospheres. You can use the other R value if you don't want to convert it, but I like to just stay consistent. Okay, so that is 760 millimeters of mercury for 1 atmosphere. So in atmospheres, that is 0.964474 atmospheres. That would be my pressure. So I have a pressure, I have a volume, I have a temperature, and I have a grams, right? It says, what is the molecular weight of the substance? Okay, so how am I going to do this? Well, molecular weight, I could find if I have density, but I don't have density. I have a V, a T, and a P. So what can I find with those? The only other equation I can use, because I don't have a density, is Pivnert, right? So let's just go ahead and use Pivnert and see what we can find. So PV equals nRT. Let's plug those in. 0.964474 times 0.2000 equals N times 0.08206 times 372.15. Okay, so I can calculate the moles. Great, let's do that. Okay, so 96474 times 0.2 divided by 0.8206 divided by 372.15. Okay, so there are 0.006316 moles of this gas. Now, what do I have? I have grams and I have moles. What is molecular weight or molar mass? The units are grams per mole, right? So anytime you're trying to find the molar mass, you just need the grams and the moles. So you just put the grams over the moles and you're good to go. So I would just do 0.851 grams over 0.006316 moles. And that will tell me my density, or sorry, my molecular weight. 0.851 divided by, that is 135, if I round correctly, grams per mole. And that could actually help me identify my gas or whatever it may be. Now, notice we didn't use the equation that I had put up here. Oh, it disappeared. I'm gonna have to fix that because I didn't have density, so I couldn't use that equation. So really the best way to approach these problems is to be like, okay, what do I have and what equations can I use?